In the summer of 1977, NASA embarked on one of the most ambitious scientific missions in human history, the launch of the twin Voyager spacecraft Voyager 1 and Voyager 2. Built to investigate the outer planets and ultimately venture into the uncharted vastness beyond our solar system, these two spacecraft were designed during a rare planetary alignment that occurs only once every 176 years. This unique configuration enabled them to use gravitational slingshots to propel themselves from one planet to the next, conserving energy and extending their reach into the farthest frontiers of space. From their inception, the Voyager probes were more than just machines. They represented a leap of human imagination, an embodiment of curiosity, innovation, and hope. Outfitted with state-of-the-art instruments for their time, telecommunication systems, magnetometers, plasma detectors, imaging science subsystems, and more, the Voyagers were built to endure the unforgiving environment of deep space. Their launch marked not only a technical milestone but also a philosophical one, as humankind sought to transcend its planetary boundaries and begin a long-term dialogue with the cosmos. Voyager 2 launched first on August 20, 1977, 2 weeks before Voyager 1, followed a trajectory that would take it on a grand tour of the outer planets, Jupiter, Saturn, Uranus, and Neptune. As it soared past each celestial giant, Voyager 2 transmitted back a treasure trove of data that revolutionized our understanding of planetary science. At Jupiter, the spacecraft captured detailed images of the planet's swirling atmosphere, revealing massive storms, complex weather systems, and the intricacies of its many moons. These included Io, whose erupting volcanoes made it the most geologically active body in the solar system, a discovery that challenged our notions about planetary activity beyond Earth. 2 years later, Voyager 2 arrived at Saturn, where it built upon the observations made by its twin, Voyager 1. While Voyager 1 had unveiled Saturn's rings and many of its moons, Voyager 2 provided deeper insights into the composition, structure, and behavior of the ring system. It discovered that Saturn's rings were not solid, static objects, but were instead composed of countless particles interacting dynamically. The spacecraft revealed subtle features such as braids, kinks, and wave patterns caused by gravitational interactions with nearby moons, findings that forever changed how we think about planetary rings. Perhaps even more remarkable was Voyager 2's journey to Uranus in 1986, a world that, until then, had remained largely a mystery. This icy gas giant, tilted at a staggering 98 degrees, rolls along its orbit like a ball rather than spinning like other planets. Voyager 2 revealed 11 new moons and 2 faint rings, shedding light on the planet's extreme seasonal cycles and strange magnetic field, which was both tilted and offset from the planet's core. The mission provided the first close-up images of Uranus's pale blue atmosphere, dominated by hydrogen, helium, and methane, and recorded temperatures dropping as low as 353 degrees C, 213 degrees C, some of the coldest ever measured in the solar system. Exploration continued in 1989 with Voyager 2's historic flyby of Neptune, the only spacecraft to ever visit the distant, ice-covered world. Neptune's deep azure hue, shaped by high levels of atmospheric methane, concealed raging storms and winds exceeding 1,200 mph, the fastest recorded in the solar system. Voyager 2's encounter also included a close look at Triton, Neptune's largest moon. This bitterly cold, retrograde orbiting satellite featured nitrogen geysers and signs of cryovolcanism, suggesting tantalizingly that a subsurface ocean might exist beneath its frozen crust. Such observations have sparked ongoing interest in the possibility of extraterrestrial life in icy, distant realms. While the Voyagers dazzled the world with images of alien landscapes and profound discoveries, they also carried a quieter, symbolic mission. Each probe bore a golden record, an ambitious message in a bottle designed for any intelligent life that might one day intercept them. The record, made of gold-plated copper, contains an eclectic compilation of music, natural sounds, greetings in dozens of languages, and photographs portraying life on Earth. Included are iconic works by Bach and Chuck Berry, The Sound of a Kiss, A Baby Crying, and greetings from a UN Secretary General and school children. These artifacts represent a conscious attempt by humanity to say, "We were here, we are reaching out." In 1990, as Voyager 1 prepared to leave the solar system, it was instructed to turn its camera back toward home. What it captured was not a grand celestial event or a distant planet, but Earth itself, suspended in a sunbeam as a tiny dot against the blackness of space. This image, known as the pale blue dot, became one of the most enduring symbols of the Voyager mission. To many, including astronomer Carl Sagan, it encapsulated the fragility and unity of our planet. Everyone you love, everyone you know, everyone you ever heard of, Sagan wrote, lived out their lives on that mote of dust suspended in a sunbeam. The image served as a profound reminder of our shared existence and responsibility to care for one another and our world. As the decades passed, the Voyager probes continued to send signals back to Earth, even as they moved beyond the influence of the sun's solar wind. In 2012, Voyager 1 crossed the heliopause and entered interstellar space, followed by Voyager 2 in 2018. This marked the first time in history that human-made objects had entered the space between stars. Despite the incredible distance, more than 14 billion miles from Earth, the spacecraft continue to operate, transmitting valuable data about the interstellar medium, including magnetic fields, cosmic rays, and plasma waves. In fact, Voyager 2's instruments recently detected a continuous, low-frequency hum from interstellar plasma, giving scientists a clearer picture of the dynamic environment beyond the heliosphere. The endurance of the Voyagers is a remarkable feat of engineering and perseverance. Originally designed for a 5-year mission, they have lasted nearly 5 decades. With only minimal power remaining, the mission teams have managed to stretch every ounce of energy by gradually shutting down non-essential systems, preserving scientific instruments whenever possible. Today, both spacecraft operate on less power than a household light bulb. Yet even in their twilight years, they continue to contribute to scientific discovery and inspire new generations of researchers and explorers. Voyager 2's final planetary encounter, Neptune, may have been decades ago, but its impact continues to ripple through the scientific community. The data collected during its journey have informed countless research papers, influenced the development of new space missions, and provided critical insight into planetary atmospheres, magnetospheres, and the potential habitability of icy moons. Missions like Cassini, New Horizons, and future endeavors to Europa and Enceladus owe much of their conceptual foundation to the path charted by the Voyagers. As the mission team now confronts the reality of dwindling power and increasing communication delays, each signal taking over 18 hours to reach Earth, there is a growing sense of reverence for the legacy these spacecraft will leave behind. One day, perhaps not far off, the Voyagers will fall silent, but even then, they will continue their silent journey through the Milky Way, carrying humanity's voice with them. Long after Earth is changed beyond recognition, Voyager 2 will drift. Onward, an emissary of our civilization, a timeless symbol of our desire to reach beyond the horizon. In the final analysis, Voyager 2's mission is more than just a story of technological achievement. It is a story of wonder, of daring, of a species looking up at the night sky and choosing to go, not because it was easy, but because it was meaningful. Its voyage tells us that even in the face of overwhelming vastness, we are capable of understanding, of exploring, and of connecting. The stars may seem impossibly distant, but Voyager 2 reminds us we have already begun the journey.